Let's see now how we can make asserts against numeric values. So here's our player character, and notice we've got this health property, and this health property starts with a value of 100. So let's go and write a test to check that the initial health is set to 100. We'll come over to our player character should tests here, and we'll add another test method. We'll call this test start with default health, and here we're going to make use of the assert.equal method, this time with a numeric value. The first parameter is the expected value, in this case 100, and the second parameter is the actual value. So this is the value that comes from our production code. Let's build this, and we'll go and run all of the tests, and we can see all of the tests pass, including our new player character should start with default health test. We can also assert that numeric values are not equal, so we'll add a new test here. We'll create our player character instance, and then as an example, we'll assert that the health is not equal to 0. Once again, let's build this to make our test show up, and we'll run this new test, and the test passes as expected. Let's head back to the player character class now, and if we scroll down to the sleep method here, notice here that when we call this method, the player character's health property is going to be increased by a random amount as calculated by this method here. So if we want to test this sleep behavior, we're not going to be able to use assert.equal because we're not going to know exactly what the health should be. And that's because the health is being increased by a random amount between 1 and 100. So let's head back to our test class. We'll add another test called increase health after sleeping. And after creating our player character instance, we're going to call this sleep method. So here we expect an increase between 1 and 100. Because our player character starts with a default health of 100, after we call the sleep method, we expect the resultant health to be somewhere in the range of 101 to 200. One way we could write an assert is to use the assert.true method and then specify this Boolean condition, so the health is more than or equal to 101 and less than or equal to 200. If we build this and run the test passes, but if we go and introduce an error here, so what we're going to do is comment out this line and replace it with another random line which will increase the health by a greater random amount than is specified in our range here. If we go and build this and run the test again, the test should now fail because the resultant health will be outside of the expected range. Notice here though in the assert failure message, we're not getting a lot of helpful information. We've just got expected true, actual false. So a better way to do this is to use the assert.inRange method. Notice here that we can provide a generic type. So in our case, this is going to be int. And for the parameters here, we've got 3. The first parameter is the actual value. So in our case, this is the player character's health. The second parameter is the low point of the range. So in our case, this will be 101. And the third parameter here is the upper bound of the range. Just as with the low value, the high value is inclusive. So here we can specify 200. So now we expect the health to be in the range 101 to 200 inclusive. Also note here that the generic type parameter is grayed out, and that's because the compiler can infer the type, so we can remove this to reduce the amount of clutter in the test code. If we build this now, and go and run this test again, it should still fail because we've got the wrong range in the production code. But notice this time the error message is a lot more helpful. It's telling us that the expected range is 101 to 200, but the actual value was 309. So let's just go and fix this up. We'll head back to our player character and return the code to the original random range. And now our test should pass once again, which it does. If we're writing tests that are asserting against floating point values, we may encounter unexpected failures of our tests due to precision or rounding errors. So let's take a look at this abstract enemy class. Notice here we've got two abstract properties, both of type double, total special power and special power uses, and also this special attack power property that divides the total special power by the number of special power uses. If we have a look at the boss enemy class here, we can see that we've overridden the total special power and set it to 1000, and also overridden the special power uses and set them to 6. So in the case of a boss enemy, the special attack power will be 1000 divided by 6. So let's go and write a test to check that the boss enemy has the correct special attack power. To do this, we're going to add a new class to our test project, and we're going to call this class boss enemy should. We'll replace these default using directives with a using xunit directive. We'll make the class public, and we'll add a new test method called haveCorrectPower. We'll create our system under test, in this case a boss enemy, and then we'll use an assert.equal to check that the boss enemy's special attack power is equal to 166.666. Let's build this, and we'll head over to Test Explorer. Notice in Test Explorer here that we're grouping by class, so we get all of our boss enemy tests under a separate grouping. Let's go and run this new test, and we can see the test fails. Notice that the expected value is 166.666, but the actual value here is 166, and then a number of decimal places ending in 7. So here, if we're happy to have this test pass with less precision, we can make some changes to our assert code. If we come down to our assert.equal here, because we're working with a floating point value, we can specify an optional precision value here. So if we only care about the first 3 decimal places, we can specify a precision of 3. If we run this now, the test is still going to fail, because behind the scenes we're getting rounding happening. The expected value is 166.666, but because we've added the extra precision, the actual 0.6666 has been rounded up to 3 decimal places, and now equals 0.667. So we need to alter our test to take account of this, and change the expected value to 166.667. If we run this now, the test will pass as expected. Sometimes when we're writing tests, we need to ensure that a value is null, or sometimes that a value is not null. So here's our player character. Notice we've got this nickname property of type string. If we scroll down to the constructor, we're not setting a default value for this property, so when we create a new player character, by default it should be null. Let's go and write a test to check this. So we'll head over to our player character should class, and we'll scroll down to the bottom, and we're going to add a new test. So we'll add a new test called not have nickname by default. We'll create our player character instance, and now we're going to use one of the assert methods, the assert.null method. This method takes a single parameter representing the object we expect to be null. So in our case, it's our player character's nickname. Let's build this, and we'll head down to Test Explorer, expand the player character should group, and just scroll down to the bottom here, and we can see our new test. We'll go and run this, and the test passes. There's also a complementary assert.notNull method. So if we change this to not null, and try and run the test again, the test will now fail, because we're expecting the value to not be null, but it is. So let's just go and fix this up. We'll change it back to assert.null, and we'll just check the test passes, which it does.